Hey, what are you doing there, Orv?
I'm just trying to hammer out an answer to that problem we've been having with balance in our aircraft.
I know we've got a problem with balance on our aircraft, but there's no time to play. We've got some serious, but we've got to do some work.
Well, sometimes play is serious work. You know, if you fool around a bit with the parts and pieces, you'll learn how they function a little bit better.
Okay, well then let me join you here. Let's see, you're doing balancing. Let's see if I can balance this ruler. You know, there's a point on this ruler. There's a point on the hammer. In fact, there's a point on any object where the object will balance. That point is called center of gravity. Center of gravity is the average location of the weight of an object, and it's the point where an object will balance. Our airplane has a center of gravity as well.
Oh, sure, and it's really important to know that because in flight, it rotates about the center of gravity. If we want to have control and understand that, we have to really find out where that center of gravity is located in our aircraft so we can have stability in the air.
Yeah, it looks like my ruler rotates about its center of gravity. You know, for a simple object like my ruler, it's easy to find the center of gravity. The ruler has a plane of symmetry. So if I can find that plane of symmetry, about 6 inches from each end, well, that's where the plane of symmetry is. That's where the center of gravity is. For symmetric objects, center of gravity is located right along the plane of symmetry.
Just like our 1902 aircraft. In 1902, the pilot lay down in the center, and the aircraft could rotate left and right about that plane of symmetry.
Yeah, that looked pretty easy. Now the hammer, though, that looks a lot more complex.
Well, of course, because it's not symmetrical. I mean, we have in the handle light wood here, and we've got heavy iron on this end, so it doesn't balance in the center. It balances more towards the heavy end. Okay, still balances, still has a center of gravity, but now it's located down here.
Okay, now what happens if you take that heavy end off?
Well, I think if we do that, we're going to shift this balance point.
Okay.
Nope, it's on there. It's not coming off. Sorry, Will.
All right. Well, suppose we add something on the end, like this clamp.
All right.
All right. Let's put this on here. All right. Now, what happens to center of gravity?
Oh, now notice it no longer balances on this end, but now it balances more towards the center.
Okay, so it looks like there's two things involved with center of gravity. It's the weight of the parts of an object, and it's the distances of the parts of the object too. And by adding a weight here, we've changed it. We're able to shift the center of gravity.
Okay. Now, I'm concerned if we try to do this in the aircraft because it's much more complex than this system.
Yeah.
If we go moving pieces and parts like we've done so far, we could spend a lot of time trying to find out a new balance point on this machine.
Yeah, you know, this sounds like a good time to use some math.
Always comes down to math.
Here's an equation that we can use to determine where the center of gravity of an object is if we know the weight of the parts of the object. What you do is you define a reference line. Then you determine the product of the distance of the part from the reference line times the weight of the part. If you sum up all the products, divide by the weight of the whole object, it determines the location of the center of gravity relative to the reference line.
Yes, and here's another issue we've got to be concerned with. We've got to know that balance point for 3 dimensions, okay? Because we're going to roll left and right, we're going to pitch up and down, and we're going to yaw left to right.
All right, well now pitch seems to be our biggest problem, but I'm always worried about roll. You know, because we've got an engine over here and a pilot over here, and we're a little bit unsymmetric. Suppose we could add an engine. You know, we need the power. We could put an engine on this side, an engine over here, put the pilot right down the middle. Voila, we solve our problem.
Well, that's an easy solution because it's going to be symmetrical, but the difficulty with that is we're adding another almost 200 pounds to our aircraft by adding another engine. We were always fighting weight, you know. That may not be the way to do it.
Okay, so it looks like probably in our lifetime, nobody's ever going to be able to fly with more than one engine.
You know, my brother didn't live long enough to see modern aircraft, but you know from your experience that modern aircraft often have more than one engine. Let's look at some pictures here. From World War II, here's a P-38 with 2 engines, and notice how symmetrically arranged they are. Here's a Ford Trimotor. Ford Trimotor has 3 engines, and on the Ford Trimotor, they're arranged 1 in the center and 1 out on each wing, still symmetrical. On a modern 747, notice the 4 engines, and notice how they're arranged. 2 on the left wing, 2 on the right wing, still a symmetrical arrangement. And there's another issue with modern aircraft as well that we didn't face, and that's the gas tanks. On a modern aircraft, the gasoline is stored in each wing. And as you burn gas, you can't burn it out of just one wing, you'll lose your balance. And so their pumps pump gasoline from one wing to the other, always to maintain that balance about a center of gravity.
You know, I've been thinking about this, and I've got an idea.
Well, you always seem to have an idea.
Okay, on this year's machine, we move the engine, and we move the radiator, we move those objects aft.
Right.
Try to change the center of gravity to solve our pitch problem.
Right?
Okay, but what we were doing there was we were moving large weights a very small distance.
Okay.
Now, based on the math that we just looked at, I'll bet we could shift the center of gravity, like you did with the hammer, by putting a small weight and putting it a large distance from CG.
That's probably going to work. You know, we've got those iron bars out in the shed. I bet we can mount them here way out on the front of the aircraft, a large distance, and move that center of gravity forward.
Well, but I don't know how we're going to get those bars to grip that front strut.
It's not a question of how it grips it. It's a question of weight to ratio. We've got to...
Let's give it a try.
All
Let's
right.
give it a try, okay?